La deuxième présentation par M. Brian Calder, Cloud-Based Volunteer Bathymetric Data Processing. Merci pour la traduction.
Good afternoon. A little earlier than I was expecting, but thank you for being here after lunch. I realized after I gave the presentation to the organizer, or the name of the presentation to the organizers, that what I should have written was what you see on screen here, is a system for supporting. I'm not going to talk about the actual processing piece. I'm going to talk about the system that we're building to support it. This project started, there we go. This project started because I was asked to make recommendations for the Seabed 2030 project about loggers that they could use in the field. And we surveyed the market for them, as you can see here. And to be honest, I wasn't particularly impressed with any of them. They're all quite expensive, not in terms of survey equipment. They're about $250 US each. That's not that bad, but if we want to scale the data collection effort, which I think we all agree that we'd like to do, $250 is a fairly expensive price point to be at. If we're going to get to a wide body of people, really to get to a true crowd, then they have to be much less expensive than that. My goal target is something around the $10 range, $10 to $20 range. So on the back of this, I asked myself a very important question, which is what you see on screen here. What is the minimum cost system that we could build to replace those types of loggers? And I'm emphasizing here that it's a system that we want to build, because just making a logger, just making the hardware, is only a part of the whole problem. Having the software infrastructure that surrounds that hardware is equally, if not more important. And none of those loggers that I showed you really had a good software infrastructure. And that's really one of the things that we wanted to try and do. Now, we did design a logger. You can see them here on screen. This is what it looks like in real life, if you just look at the one I'm holding up here. It does NEMA 2000 logging through this interface here. It does NEMA 183 interface logging through this interface here, two separate channels. It has inside all the associated electronics, 8 gigabyte memory card. We've tested it up to 32 gigabytes. That's good for probably at least 6 months to a year of average data collection. It also has a small motion sensor on board as well if you need to use it. I'm happy to show this to people later. This one, is, you probably can't read it from back there. It says CHS 10 on the side. This is one of the ones that we've made. We're giving it to Mathieu after the presentation here. But that's only part of the story. So the whole structure that we wanted to build looks like this. And so the concept of operations that we wanted to get to here was the idea that loggers would be in the field collecting data. Every so often that ship is going to come back to port. And at that stage, we want somebody to go up to the ship with their mobile device, tablet, laptop, phone, pull the data off the logger so that the person who is hosting the logger on their boat does not have to do anything to make the data available. The data gets aggregated on your phone and then gets sent up into the cloud for processing. To demonstrate this system, which is all open source, including the hardware, it's all available from our site, which is there. We built a very early version of this, but in the process of building the early version, as any of you who have done development work will know, you learn an awful lot about how not to do what it is that you want to do, and you learn what to do right for the second time around. What I'm going to talk to you about is that second time around. What we learned from doing this first implementation is that we had originally designed it to use Bluetooth. And that's because I didn't want to have another Wi-Fi network running on a boat. And the idea was you come up, you start with Bluetooth, turn on the Wi-Fi to get the data performance, and then the Wi-Fi would go off again. It turns out that Bluetooth, not a great idea. It uses a lot of resources on a very small computer. And so basically you can't use it in effect for any length of time without it all going horribly wrong. So We had to find a better way of getting the data off the logger. We also found that deploying the cloud portion, we provided the full instructions for how to do it, but it's not easy. It takes a bit of effort, takes a bit of understanding, takes a bit of experience. Our goal for this project is for it to be simple enough that anybody could use it. Your local yacht club, for example, if they wanted to collect their own data, they should be able to do that. They can either buy or make their own, they can get all the software from us, deploy it themselves, control their own data, which, as we heard this morning, can be important for indigenous communities, for example, who are doing collaborative or participative data collection. It wasn't as easy as it should have been, and so we fixed that. It was also fairly static. We had a very straight processing path, a very clearly defined processing path, but that made it quite inflexible. If we want to add new things in, we have to improve on that, and I'll show you later how we did that. And then finally, visibility. The initial system, you really couldn't see what was happening inside. So if your files didn't convert properly, if they didn't process properly, you could find out, but it wasn't easy. And so we wanted to try and make that better as well. So I'm going to go through each of these in turn and show you what we did to make that better and describe the system in turn as it exists now. So the first stage was that input stage. How do we get the data off the logger? Well, eliminating Bluetooth actually led to a much simpler solution for us in the end. What we do now is we run a Wi-Fi system on the logger, so it boots and it starts its own Wi-Fi from the logger, so you need no infrastructure. And it automatically boots in that mode now. That lets us run a web server on this little device here, so anybody with a browser can go up and access the data off the web server. We also provide, however, a REST endpoint hosted by this system so that we can do it from anything. You know, laptops, desktops, cloud server, doesn't matter. As long as it can get to the network, you can get the data off that system. That gives us a great deal more flexibility. And that's how the data now comes off in the flow path on the top there. You'll notice that we also put in a converter on the bottom. We actually get asked, can you use this with alternative data loggers? And that happens often enough that we built that in. So that if you have somebody else's data logger, you can convert their data into our format and then use all the rest of our infrastructure as well. And that, we provide all of this software as part of the project. This is one example of how we might do that. This is a Python-based, very simple Tkinter GUI that allows you to connect to the website of the logger and send it commands and get data back off and do things like do full configurations, which used to be quite difficult to do. Now you can load your configuration as a JSON file and then write that into the logger and retrieve the current configuration, set up defaults and that sort of thing, which was actually a recommendation for one of the people sitting in the audience here, is to have some factory defaults in case everything went wrong. You'll be glad to know it now has factory defaults. But you can do this also through a web browser. Eventually, it's not quite there yet, but eventually what we hope is that this will actually host its own website, which you will have everything in it to do its own configuration runs as well. The setup, the deployment piece, the way that we did it initially was we said, well, you go to the Amazon websites and you use their consoles, which look like this, and they're very complicated and they're difficult to use. We provided full instructions, but it was not trivial to make that happen. And so what we've done instead with that is we've gone to an idea of infrastructure as code, meaning that we provide the code that you need to set up your infrastructure directly from your desktop machine. What that looks like in practice, and this will be too small for you to read, but I'm happy to share the presentation with you later if you want to see it. On the left-hand side there, your left, my right, there is a configuration script. And that configuration script allows you to set things like the identifier that you use to talk with the archive, for example, or where you want to deploy, which region of the Amazon infrastructure you want to deploy into. Once you configure that, and it's really only one or two things that you need to configure, the script on the right-hand side there will then take that configuration and deploy the entire infrastructure for you with no further interaction with you. You authorize it, it runs through and does its thing. There are a number of different ways that you could do this. There are things like the serverless option, which you can use. It allows you to do the same sort of thing. Amazon have their own version. It's called CloudFormation, where you can do basically the same thing. We've decided to keep it simple like this because the fewer services we include, the easier it is for other people to use this system. And we're talking, remember, about people who may not have any experience with working in the cloud, who are going to try and do these deployments. So we try to keep it as simple as we possibly can. The one thing that we are thinking about here, though, is we could also do this as Python and use the Python API rather than command line tools. There are some advantages in that. We may go there eventually in the future, but at least for now, this is relatively straightforward. You do need something which is Unix-like to run this script, so macOS, Linux, or Windows subsystem for Linux to be able to run it. The third problem was flexibility. And what I mean by that is the ability to add new things into this without having to rebuild the entire system. By way of example, this is the IHO's recommendations document for volunteer bathymetry, or crowdsourced bathymetry if you prefer. Inside that document, it has a whole list of what the metadata should look like that goes with your system. Unfortunately, however, that metadata is just a table, and although they provide examples, which is the script on the right-hand side there, there's no description of how you go from the left-hand side to the right-hand side. And so there's a lot of variability between how different organizations write the metadata that goes to the archive, which makes things very difficult for the archive. We wanted to make that better, so one of my colleagues at the university wrote a validator for that metadata, so it can check automatically if the metadata is in the right format, and the website or the GitHub repository is down at the bottom there, and I'll remind you about that at the end as well. But what we want to be able to do is to add things like this into our processing without any extra complexity. So what we've done to do that is restructured how the processing works. And so as the data comes in, every component of the structure now is designed so that it will provide notifications when things happen. And we can use those notifications to give us a data-triggered environment, which we can then very easily add new things into. In this particular implementation, it's all in the Amazon infrastructure, so what we're using is a thing that's called Simple Notification Service, or SNS. And that's the purple icon you can see there on screen. And after we upload the data, we then trigger the SNS to say a new file has appeared, which can then get picked up by the next stage of processing to do the data conversion, for example, or anything else. It doesn't have to be just one thing. So at every point where you see that purple icon, we have the option to trigger one or more things happening. So we can very easily fan out into multiple different things that a particular processing system has to do. By way of example for us, that's the metadata validation. Now, as you can see from this, the metadata validation does not make anything new. All it does is give you an indication to say, yes, that data is valid, which again makes it much more flexible. In our first implementation, you had to make a file. We don't have to do that anymore. And then the last stage of the current processing scheme is we send the data out to the archive at the IHO archive data center for digital bathymetry, which is at the NOAA data center in Boulder, Colorado. So doing it this way has allowed us to have much better flexibility in how we add new things in. It's very easy, for example, for a country where they say, well, you can collect volunteer data, but we want to see it before you send it to the archive. That's very easy to do now. For a community, for example, in an indigenous community, if they decide that they don't want to send the data outside of their community, all you do is turn off that last stage, and the rest remains the same. So it gives us a much better flexibility here, kind of a microservice almost architecture. The processing steps here are all Amazon Lambdas, a serverless technology, so we don't have to pay for having servers up all the time. One of the design principles here is to try and keep the cost down as much as we possibly can, because we expect volunteers to be running this, or at least a group of volunteers, like an indigenous community or a yacht club or a local harbour or something. The last thing that I mentioned as a problem was visibility. Can I see what's happening inside the processing system? So what we've done there is a slightly more involved system, because it has to run all the time. It can't just be triggered by the data. But what we've done is try to minimize that cost. So we now have a monitor system that has a database that keeps a track of all of the files which have come into the system and their current status. So it keeps track of where they were, where they came from, who generated them, when they were uploaded, when they were processed, and so on, whether it was successful or not, and so on. If you've worked in the Amazon infrastructure before, you might be able to read some of the icons, but I'll tell you what they are, because they're new to me too. The green icon means that we're using what Amazon call elastic file service. That's the bit that gives us continuity, so that the database survives over multiple runs. The icons on the left are for elastic container service. This runs as a Docker container. But also we use Fargate, which is Amazon's serverless container service, meaning that you don't have to have a computer running all the time in Amazon's cloud for this to work. When it's required, the server will start. When it's not being used anymore, the server will drop off, which means that we can keep the costs very, very low so that people aren't paying very large cloud costs to be able to run this service. As you can see at the very top there, we provide a REST API, so we provide a way for people to communicate with this from the outside world. So with a browser, you can get a dashboard and see which files are being converted, when they're successful, and so on and so forth. And also we can do notifications. So every day, you can go through and say, how many files didn't work, and then send that out as an email, so that for the people who are doing this, you don't have to be watching their cloud service all the time. When something doesn't work, it'll follow you to your phone, which makes things a great deal simpler. So by building up this structure, what I think we've done is we've given ourselves a much better place from which to build new systems. Remember, our goal with this project is for it to be something that's flexible, so that even people who are not specialists in this can run this system. I want anybody who wants to be able to collect their own data to be able not only to collect their own data, but to own their own data as well. But at the same time, by providing this scheme, particularly that last section where the data goes to the archive, what we're doing is making it simpler for everybody involved, because we can make guarantees that the data is in the right format before it goes to the archive. So the archive doesn't have to deal with 300 people all making different versions of data. The archive has a guarantee that the data is in the right format. The people who are collecting the data don't have to worry about it. And we've designed a system so that we minimize the costs, so that running this thing for a year should be, we hope at least, less than $100. Well within the capability of even small organizations who want to collect their own data. The other key issue, which took us some time to realize that we had done, wasn't actually by design, but that's how it works. Because we're making all this available as open source, anybody who wants to do it can get it, which means that anybody can collect data and it doesn't have to come through us. Which means when you want to go to scale, that's easy, because there's no one organization in the center which becomes a bottleneck eventually. So we can do what we call federal scaling with this, so that we don't have to worry about making this into something that scales to very large data collections. I'll put up some contact details there. Those are the URLs for the two repositories that we're using. The QR codes will also take you to the same place. In the meantime, thank you for listening. I'd be happy to answer questions.
Merci, thank you. Andrew. Est-ce qu'il y a des questions? Gênez-vous pas, on a un service de traduction, donc la question peut être en français également.
Thank you very much for the presentation. I wonder what is the legal status of all the research that you've done and the status of the software and the hardware. Is it publicly available?
Yes, it is. Everything that we've done is open source. The hardware design is open hardware. We publish all the design files that you need to make your own. We've published the Gerbers, full schematics, the bill of materials, in the format so that if you go to the recommended fabrication house that we've used, you can just go to their website, click, 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 and about 10 days later your boards will show up in the mail. We also publish as open source all of the firmware for the runs on here. We publish all of the source code for the mobile app. There's a special mobile app. The desktop app that I showed you, and all of the cloud services and everything else, all open source. So in terms of, you asked about legal status of the research. I don't know if that's a translation issue, but the legal status of volunteer data is actually quite a complex process, but it is something that the IHO have been paid very careful attention to, and it is addressed as part of the guidance document. The bottom line is that different countries have different opinions about how that data should be handled, but the archive has mechanisms in place to make sure that if a country says, you may not do that in our world, you can still send the data to the archive, and the archive will just store it until the country changes its mind or comes up with better ruling. So it's a significant question, but it is something that has been addressed.
D'autres questions? I have one question. How many of those small modules you have made so far?
It's a good question. So we currently have 35 in the field. We've probably made about 50 in total as we've built the new ones, built new versions of them. This one, you can see it, this one says CHS 10. We made 10 for the CHS. We also will have 15 at a project in southern Florida, in Tampa Bay, as of the end of April. CIDCO have 2, and Orange Force Marine have 2 as well. So there are a few others around the world. We are also working with a partner organization. It's called CID, like SEAID. They're making commercial versions of these in volume starting May 10th. And you'll be able to, these ones you'd have to make yourself or convince us to make them for you, which is not easy. As of May 10th, they'll be taking orders. So if you want to buy them, rather than make your own, you'll be able to buy them in volume through them.
Thank you very much.
You're welcome.